As I mentioned in the other video, the vertex form is really sort of custom made for graphing parabolas. Y minus k equals a times x minus h quantity squared. And the reason it's so custom made, the reason it's so nice for that is all we have to do is look at what k and h are, and the point hk is our vertex, and then we just look at the sign of a, and we can tell whether the parabola goes up or down. A negative a is a down parabola, and a positive a is an up parabola. So we can get a really quick, just sort of educated guess at where that parabola goes on a graph just by looking at the actual expression. What I want to do is play with some values using the Desmos graphing calculator at www.desmos.com, so we can get a feel for what happens as k and h and a change values. So let's open up that calculator real quick and I'll show you what I mean. So here I have, let's actually clear this and we'll type these back in. I'm going to type in just the standard form, y minus k equals a times the quantity x minus h squared. And you'll see that it assumes that I want to have x and y stay variables for the graphing, but that I may want to use sliders for these other variables, k, a, and h, so that I can change the values and see what they look like. So I'm going to go ahead and click all, turn all three of those into sliders, and it's going to default to 1 as the value for each of those. So this line that's graphed right here now is actually y minus 1 equals 1 times x minus 1 squared. So we have 1 for k, 1 for a, and 1 for h. And you can see that since our vertex is hk, here it's at 1, 1, because h and k are each 1 at this point. Now if we want to go through and see what happens as these values change, all we need to do is slide the sliders left or right, and you can see that as k increases, that parabola moves upward. K is the value that's associated with the y variable, which is our up-down variable, so it certainly makes sense that it would go up as it increases, and then it also goes down as it decreases. As a becomes more negative, the parabola slides down. So as k changes, we're affecting the vertical location of our parabola. Let's set this back to 0 for now and see what happens when we change h. Now, h is the variable that's associated with x, which is our horizontal location. So as h gets more positive, our parabola slides to the right, and as h gets more negative, our parabola slides to the left. So I think that makes pretty good sense. So as long as we're adding or subtracting a number inside the parentheses with x, we're affecting the horizontal location of our parabola. And then finally as a becomes more and more positive, the parabola gets narrower and narrower, and as a gets down to 0, we actually get a flat line, and that's because then where a hits 0, we actually have y minus whatever, y minus 1 or y minus whatever we have equals 0 times x minus h, whatever h is, squared. Well, 0 times anything, which is why I said whatever h is, it doesn't matter. 0 times anything is 0. So then, oops, and I should have left this as k. So right now we have k is 0, that's what it's set at. So now we just have y minus k equals 0. And now as we adjust our k, you'll see that that straight line just moves up or down, because we're just subtracting a number from y to make it equal to 0. So that 0 flat line tells us we're not getting any curve at all. And then as a gets into the negatives, that parabola starts to go down. You can see that it'll curve down as soon as a gets to be a negative number, and then as a gets to be more and more negative, it gets to be a steeper and steeper curve down. So when negative a goes down, positive a goes up, positive h goes to the right, negative h goes to the left, positive k goes up, negative k goes down.